Hi, sorry I'm late. Has anybody got any questions about anything before I start? Can everybody hear me okay? All right, well, I'm going to start. This is section 4 of chapter 5, and we're going to do some more with analyzing graphs of these rational functions. And remember, a rational function is pretty much just an ugly looking fraction, like x plus 3 over 2x squared plus 7. There's an example. All right, so their example is this one. And they're going to take it through step by step and show you how they're going to analyze it. How they're going to figure out what this graph looks like. All right, so step 1 is figure out what is the domain. And in this one, the domain, they took the numerator here and they factored it out. It's an x squared minus 4. So it gives you an x plus 2 times an x minus 2. X squared minus 4 is a difference of 2 squares, and it factors into conjugates. But my denominator is an x, and denominators cannot equal 0. So they said, well, the domain can be anything except 0 because there's just an x in the bottom. So x itself can't be 0. And then after they factored it, they looked at this right here and they said, okay, we factored it out, but we can't reduce it anymore. So the function is in lowest terms. And then because x cannot equal 0, there is no y-intercept. Because remember, the y-intercept is always when x is 0, and then it's going to be somewhere on the y-axis. But x can't be 0. So there's no y-intercept. It does have 2 x-intercepts. The x-intercepts are when y is equal to 0. So they put the 0 where r of x is, because that's really your y. And ultimately what they had was this thing here set equal to 0. So they have the x plus 2 times the x minus 2 all over an x. They're like, okay, we'll let y be 0. So they put 0 there. In order to solve for x, the first thing you have to do, clear out the denominator. So they multiplied both sides by x, cancels out here, and then you still get 0 on the right. And you're still left with the numerator of x plus 2 times x minus 2. And then all you have to do is look at that and you're like, okay, this x-intercept would have to be positive 2, and this x-intercept would have to be negative 2, which is what they said right here, negative 2 and positive 2. That's how they got it. And they each have an odd multiplicity because this is x to the first plus 2 and x to the first minus 2. And the multiplicity on that will tell you whether it touches the graph or crosses the graph. Remember, if it's odd, 1, 3, 5, 7, it'll cross. So these will both cross the x-axis. It won't curve and touch it, it'll cross right over it. And then the real zero of the denominator was 0. So the graph of R has the line x equals 0 as a vertical asymptote. Remember, whatever's left out of the domain, that's where your vertical asymptotes will be. And the denominator was just x equals 0. And x equals 0 is, here's the x-axis, here's the y-axis. This is where x is equal to 0, and you would draw a vertical line right through that. That's your vertical asymptote. And of course, x equals 0, that's really x to the first, so that is also odd. Now, when it comes to the asymptotes, this is where it's a little different. When it comes to the asymptotes, if it's odd, then that means that if you think about it, one end will be up and the other end will be down. So one side will be approaching positive infinity and the other side will be approaching negative infinity towards the asymptote, if it's odd. If it's even, they'll either, put a different color in here. If you had one that was even, then, you know, both ends are going to be going up. So they'll both, on both sides, be approaching infinity, or both ends will be going down, which means on both sides of the asymptote, they'll be approaching negative infinity. But since ours is odd on one side, so like, for example, use a blue pen in this one. Whatever our graph looks like, on one side, it's going to be going up like this, and on the other side, it's going to be going down like that. It'll be approaching positive infinity on one side and negative infinity on the other. This one's going up, so it's approaching positive. This is going down, it approaches negative. Or it could be the other way around. It could be going downward on this side and going upward on that side. I don't know just yet. I just know for sure that it's, you know, doing one of those two things. Remember, we're analyzing it. Okay, now, the other day, last Wednesday, when I was going over section 5.3, I said to you, I'm just gonna leave this slide in your PowerPoint, even though in this section you won't need it. Guess what? In this section we do. It was the slides that showed long division. Although theirs was extremely complicated, the ones that I've had to do in our homework aren't that hard, so hopefully it won't be so nasty. But let's see. That was the real zeros. Okay. Since the degree of the numerator is, and this part I did go over with you last time. Since the degree of the numerator 2 is 1 greater than the degree of the denominator 1, then it's going to have an oblique asymptote. And to find it, we have to use long division. So when I was looking at my function, which was this right here, x squared minus 4 over x, it was x squared minus 4 over x. The degree of the numerator is 2, and the degree of the denominator is a 1. If there's a difference of 1 between those two, you're going to have an oblique asymptote. And to find it, you're going to have to do division, long division. So you take the numerator, this x squared minus 4, that's going to go underneath the division sign. or the little division box thingamabobber. And then the denominator goes on the outside, and that's what you're going to divide by. Now, if you don't remember how to do long division, let me refresh your memory real quick. Let's say I wanted you to divide 3 into, let's say, 51. You know, old school, or as I like to call it, math, BC, before calculators. Funny joke. Okay, remember you would divide, you'd be like, okay, 3 divides into 5. How many times? 1 whole time, and you put it there. Then you would take the 1 and multiply it times the 3, and it would be 1 times 3 is 3, and you'd put it there. Then you'd subtract. 5 minus 3 is 2. And then you would drop down the 1 and start the whole process over again. 3 goes into 21 7 times. 7 times 3 is 21. When I subtract, I get 0. There's no more to drop, right? No more to drop, and you're done because you're at 0. So the answer is 17. That's long division. Fun times. But you're doing this with polynomials. The process, though, the thought process is still the same. You divide, you multiply, you subtract, you carry down. So I'm going to rewrite the problem over here. They're taking x and dividing it into the x squared minus 4. So you're like, hey, x divides into an x squared, x times. I actually think of it like this in my head. I'm like, I have to take x squared and divide it by x. That's x to the second divided by x to the first, and the rule says subtract the exponents, so you would take 2 minus 1, and of course 2 minus 1 is 1, but x to the 1 is just an x. And that's what I put right there. And then of course you'd multiply. You're like, okay, x times x, you're going to multiply here. I'll use a dot instead of an x. X times x is an x squared, and then you draw your line and subtract. X squared minus x squared is 0. And then you would drop down the -4, but 0 minus 4 is a minus 4. And at this point, if I try to divide again, x doesn't divide into negative x at all. This right here is my linear function. So the line, and it says down here, let me grab a highlighter. The quotient is x, so the line y equals x is the oblique asymptote of the graph. Now, in a couple of these, you will have to do an extra set of division, and the one I picked out from my math lab does that. So when I get there, we'll do it together, if you're still awake by then. All right, what's next? Let's see. Oh, then, and sometimes you might have part of your graph intersect an asymptote. That asymptote may be there for another part of the graph, because sometimes you have a funky graph. So you have to look and see, is there any chance that part of my graph might touch one or both? Sometimes you have 2 or 3 asymptotes. So I don't know if any of you remember this, but when we were solving, I think I did it in this class, or maybe you did it in a class previous to this one. When you solve a system of equations, like 2 lines, and you graph them, you like graph one line and then the other line, and you're looking for the point where they intersect, but graphing isn't always the best method. So one thing you can do is just take your 2 equations and set them equal to each other. Like if the green line was y is equal to, I don't know, 3x plus 5. And the purple line was y, actually this would be negative, that's going downhill, negative. And let's say y was, I don't know, 2x plus 7. If I took the, since they're both set equal to y, if y equals 2x plus 7, but y also equals to 3x plus 5, negative 3x plus 5, then that means the negative 3x plus 5 is going to equal the 2x plus 7. And if you solve that equation, you will find the X-intercept, or the X coordinate right here of this point. And then all you'd have to do is plug it in here or in here and find the Y coordinate. And that doesn't work just for lines. I could have a line intersecting a parabola, or a line intersecting a cubic, or two parabolas intersecting each other. If you set them both equal to y, you got y is equal to this stuff and y is equal to that stuff. If you take the this stuff and set it equal to the that stuff and solve for the x's, you'll have the x coordinates of your intersection points. So that's what they did here. They had this vertical asymptote of y equals to x, but our original function was r of x is equal to all of this stuff. So they just took the, they took the r out of it and they just left this part here. So it's like, that's our y. That's the same as y. So they're just like, forget that. So they took the stuff I highlighted in yellow and they set it equal to the stuff I highlighted in X, because they like, said, well, we don't need that y equal, that y part equal. Either, not equal, either. If y is equal to this, but y is also equal to that, then my this is equal to my that. Pink, not yellow. So they took that ugly equation, this mess right here, and they said, all right, we're going to solve that for x. First thing they had to do was clear out the fraction. So they multiplied both sides by x. They took the x squared minus 4 over x is equal to x, and they multiplied both sides by x, so that this x canceled that one. And so you can see they're left with the x squared minus 4 on the left, that's this right here, and then x times x, that is x squared on the right. And then something fascinating happens. At this point, they've got x squared minus 4 equals x squared. And then they're like, okay, I got to get all my x's on one side. So they subtract the x squared off of the left so that you have a negative 4 by itself on the left. But then on the right, uh-oh, they cancel out over there also. And you got a 0. Negative 4 doesn't equal 0. What does that mean? It means there's no solution, which means R does not intersect the oblique asymptote. Whenever you're solving an equation and your variable just disappears, that means there's no solution, which applied to this situation means there's no intersection between my original function and my oblique asymptote. Now the fun part begins. Not that we haven't been having fun already. Okay, we now have to get an idea of what this graph is doing around the zeros. Now, my numerator had a couple of zeros. They were -2 and +2. My denominator had a 0 of 0, which means if I looked at a number line here, and I look at the numbers, let me get some brighter colors here. Yeah, green will work. Yeah, those work. If I look at the -2, a +2, and a 0, and where they're located on a number line, those 3 numbers, you put them from left to right, smallest to largest. So -2 is here. 2 is there. Hello, April. 2 is there. And 0 is here. And keep in mind that this is a number line. So you've got negative infinity way down here. And at the other end, you got positive infinity. And so this has now been divided up into 1, 2, 3, 4 intervals. My first interval is this one, which goes from negative infinity up to the -2, but doesn't include it, so parenthesis. Then we've got this interval, which goes between -2 and 0. Then we got this interval, which is between 0 and 2. And we've got this interval, which goes from 2 to infinity. Now keep in mind, those zeros are where the graph is either an X-intercept or it is an asymptote, one or the other. And you have to figure out what's the graph doing in each one of those 4 intervals. So they have made a table, which I will also. So here's their picture. You can see, here's the 2 to the 0. And I think I used green here. That's purple, April. Come on, pen. Green here. And yellow is here. And pink was here. All right. So what you're going to do is pick a number somewhere in those intervals. So for the first one, you can pick any number you want from negative infinity to -2. They picked -4. You could have picked -3, you could have picked -5, you could have picked -257 for all I care. I would choose small numbers though, because you're gonna have to do some plugging and chugging. Now, the original function, what was that original function? It was x squared minus 4 over x, right? So they took, for each one of these problems, they're going to take whatever number they pick and they're going to stick it where the x is. So in this case, they're plugging in -4. And that gave them, for the numerator, positive 16 minus 4 is 12. 12 divided by -4 is -3. And that's what they got right here. Look at that, -3. Now, since the y coordinate, remember the value of r, they write r of -4. It's just your y coordinate. Since it is negative, that means you are below the x-axis, either in quadrants 3 or 4. In this case, it's 3. Here's the point, -4, -3. That is in quadrant 3. If you are below the x-axis, or if you are a negative y coordinate, that means you're located below the x-axis somewhere. I don't really care what quadrant it is. It could be in 3 or 4. I just need to know it's below the x-axis. Now for the next one, there goes that cat again with the water fountain. They pick somewhere between -2 and 0. There's only one whole number between -2 and 0, and that's -1. Doesn't mean you can't use a fraction or a decimal if you want to. I know some of you crazy kids out there like to work really hard and pick really hard numbers. You can. But they did the same thing, and instead of -4 here, they plugged in the, now they're plugging in -1. -1 here and here, which is gonna recalculate to be -1 is 1, -3 over -1, which would be +3, and there's their answer. Because it's positive, you're gonna be above the x-axis. And then they did the same with the green and the purple. I won't bore you. They're just plugging and chugging, looking at what the answer is. Since it's negative, you're below. Since this one comes out positive, you're above. So you've got an idea of what your graph, where your graph is located at these particular points, above or below the x-axis. Now, you guys you're going to have multiple guesses when you get to the graphing part. So they're not actually forcing you to graph. But here they're actually graphing all those points. And then they drew in you can see the pink dotted lines. You've got the oblique one, and then the vertical one is right here. It's hard to see on top of the y-axis, but it's there. So they plotted the points, they drew in the asymptotes, and then they took into consideration all the things that were just said about being below or above the graph and whether it crosses the x-axis and all that. And they came up with that. And some more about going towards infinity or below infinity. I already talked about that. And then here's the final outcome. That's what it looks like. Beautiful. Okay, and then they have another one. Now this one's much more ugly. The first thing they're going to ask you to do is to put it in factored form. So I can factor out a 3 and an x from the numerator. That'll leave me with an x minus 1. And my denominator is, I'm going to unfoil this one. I need 2 factors of negative 12 that add up to positive 1. So that'd be a negative 3 and a positive 4. So that's the first thing they do here. There it is. They factored it out. And that would be in lowest terms, because when you look at this, no factor in the numerator will cancel out with the denominator. Since the denominator is x plus 4 and x minus 3, x cannot be a negative 4 and x cannot be a positive 3. So those are the numbers left out of the domain. And then they went through and they said, okay, the y-intercept is when x is 0. So they stuck zeros in all the x's and they came up with 0, which is the origin, 0, 0. Let's see. Anyway, they're just going through all of this again with you. It would be easier if I just kind of did it with you in my math lab. So you can look at these later if you want. I don't want to have to read through all this. I just left them in the PowerPoint for you as extra examples, but I'd like to just go straight because I got 45 more minutes and I've got a bunch of examples. I got 3 or 4 examples, so. But they're long. I mean, there's like 11 parts to some of these questions. So there's only 14 questions in the assignment, but several of them have 11 parts. So now this one just says 2 parts. It says for the graph of r of x equals blah, 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 find the following. Well, find the domain. Remember, when you're dealing with the domain, it has to do with the denominator. All right, we're in rational functions here. So if there's an x in the denominator, remember that the denominator is not allowed to equal 0. So if I add 9 to both sides, that cancels. I'm left with x is not allowed to be a 9. So that would be, it's a drop down box. I will click on that one right there. And the next one, what are the X-intercepts? Okay, the X-intercepts are when y is equal to 0. So we are going to stick a 0 right here. We're going to say 0 equals x times x minus 9 squared all over an x minus 9. But I can reduce that because x minus 9 over, I got an x minus 9 in the bottom and I got 2 x minus 9s in the top. Well, what about that? That one will cancel out one of these, leaving you with 1. So I'm at 0 is equal to x times an x minus 9 to the first. And X would have to be a 0 to get a 0, or X would have to be a 9 to get the 0, to get a Y coordinate of 0. But, but if you remember, X can't equal 9 because he's not in the he's in the denominator also. So in theory, he can't be an X-intercept because X can't be 9. It means he's going to be an asymptote, not an X-intercept. So the only correct answer on part B is 0. That one you had to think about. Most people pick, well, heck, they didn't even give you a choice of 0 and positive 9, did they? I don't know why. Seems like they would, just to trip you up. I would. You know, that's how I like to roll. You know, trip up those students. We don't make much money, so we gotta have fun doing something. Number 5. All right, this is the first one with 11 parts, and it will end with, which is the right graph of this mess right here? What's that look like if you graph it? Okay. First things first, if needed, first write the given function as a single rational expression and then factor the numerator and the denominator. State the correct choice below. This thing already is in factored form. I see parentheses in the denominator and x plus 8 can't be factored, so that's choice B. It cannot be factored any further. All right. Next question pops up, and you're going to get 11 different positive affirmations. So here's your first one. Good job. There you go. What's the domain? Well, the domain has to do with the denominator, and my denominator is x and an x plus 12. The denominator is not allowed to be 0. So x is not allowed to be 0, and x is not allowed to be a negative 12. So I'll put x is not equal to 0, comma, negative 12, or in the opposite order, whichever floats your boat. And then remember, when you get to the part where they ask about your vertical asymptotes, those are both also vertical asymptotes. So try to make a mental note of that. All right, so then I get another get, let's see, let's get an excellent this time. Excellent, there you go. And you'll hit enter again, and the next question pops up. And it says, put this in lowest terms. Well, it's factored out. Can you cancel anything? No. I can only cancel an x plus 12 with another x plus 12. And you cannot cancel the x with the x in the x plus 8. It's all or nothing. You either cancel an entire x plus 8 or you don't. If it helps, put this in parentheses so you don't accidentally cancel those x's, because you can't. So this one's already in lowest terms. Can't do anything with it. Then it says locate the intercepts, and I apologize, I did not leave enough room on this paper to do all this work, because the x-intercepts is when y is 0, and the y-intercepts is when x is 0. So if you don't mind, I'm going to put in another piece of paper in here, a blank slide, because I kind of left out room. Okay, and my function was r of x. I just like to put y. Y was equal to the x plus 8 over an x times an x plus 12. Now, your y-intercept is going to be when when x is 0. So I'm going to put a 0 here and a 0 here and a 0 there. But right there, I can see 0 plus 8 is 8, and then this is going to be 0 times 12. But 0 times 12 is 0, and 8 divided by 0 is undefined. So there is no y-intercept. This thing does not cross the y-axis. But you know what? If I'd thought about it, if I go back to boop, right here, remember what I said? 0 and negative 12 are not in the domain because they're asymptotes. And x equal to 0 is a vertical line going through the x-axis at 0, which is also known as the y-intercept. So there's no y-intercept. And then the x-intercept is when y is 0. So this one will be a little bit more complicated. I am going to put 0 where the y is. And then I have to solve for x. Unfortunately, I have a nasty fraction. So the first thing I am going to do is clear out the denominator. I'm going to have to multiply both sides by the denominator of an x times an x plus 12 so that this cancels that. But what you do to one side, you got to do to the other. So I have to multiply the other side by an x times an x plus 12. But 0 times anything, even an x times an x plus 12, is 0. And of course, it canceled out over here. So I'm just left with the numerator of x plus 8. That'll happen every single time. When you multiply out, if you want to cancel out the denominator, it's like it gets absorbed by the 0 on the other side. All you'll be left with is the numerator. And of course, if I solve this for x, I'll get negative 8 is equal to x. So my x-intercept is negative 8, 0. So I'm going to go back to the slide and pick out the correct choice. The graph has no y-intercept, so it's got to be, it's B. The graph has an x-intercept. Let's see. Simplify your answer, type an integer or a fraction, use a comma to separate answers as needed, type each answer only once. Okay. The graph has x-intercepts of negative 8 and no y-intercept. Surprised they didn't ask me to type it as an ordered pair, but they didn't. Okay, and so, oh, I forgot my positive affirmations, my bad. How about yay? Let's just make some up. And how about you rock? There you go. Let's see. Determine the behavior of the graph at any x-intercept. So we have to now decide the behavior of it at the x-intercept. We know it's going to go through that point because it's an intercept, but does it cross or does it touch? Well, what were my x-intercepts? My x-intercept was negative 8, which came from the numerator, right? It was this guy right here. And an x plus 8 is to the first degree, which is odd. And if it's odd, it's going to cross. And there's only one x-intercept, so it's going to be choice C. The graph will cross the x-axis at x equals negative 8. Here's your positive affirmation. Sweet. All right. Determine the vertical asymptotes. This is where I said make a mental note before. I believe I used the color blue before. That was when we had 0 and negative 12. There were 2 vertical asymptotes. This one says 3, this one says 2, this one says 1. It's this one. There were 2. Now, it says the leftmost and the rightmost. Our numbers were, this one here was 0 and this one was negative 12. If you look at an x-axis, here's an x-axis, one of those numbers is here and one of those numbers is there. From smallest to largest, you would hit negative 12 first and then 0 second. The negative 12 is the leftmost and the 0 is the rightmost. Hope you remember your left from your right. So, oh, another important thing. It says right here, type equations. So these are vertical asymptotes, right? Vertical. They're going through the x-axis at those numbers. So it's x equals -12. That would be the equation of a vertical line going through the x-axis at -12. And the rightmost is x is equal to 0. Those are their equations. There you go. You're going to get an awesome this time. Awesome. So many positive words out there. Okay, and next says determine the behavior. All right. When they want you to determine the behavior on either side of the vertical asymptotes, you want to look at multiplicity of the, I guess the zeros that you got, the zeros, which were the x and the x plus 12, they both have a multiplicity of 1. I'm going to abbreviate multiplicity. Multiplicity of 1, which is odd. Now, these are asymptotes, so you're not crossing an asymptote. You don't cross or touch an asymptote at all. You're trying to figure what the graph is doing on either side. Now, I'll use the same concept with this as I do with graphs and their end behavior. Remember, if it's an odd, one end will be up and the other end will be down. If it were an even, both ends would be up or both ends would be down. So in this case, if one end is up, it's going towards positive infinity. The other end is down, it's going towards negative. If it's even, then both are going towards positive infinity or both are going towards negative infinity. All right. We are this one. Both have a multiplicity of 1. They are odd. So they're both, it approaches infinity on one side of the asymptote and negative infinity on the other. It's going to be C. It approaches infinity on one side at x is equal to and negative infinity on the other. And my two vertical asymptotes, once again, were the 0 and the -12. So same numbers again. Now, which one's going up and which one's going down, I'm not sure yet. That's when you break it up into the intervals and do the little number line chart and all that. Okay, so I got the right answer on this one. So it's another positive word. Booyah! Feel free to shout out a positive word. Okay, next, determine the horizontal asymptotes. Okay, we did this the other day also, last Wednesday. This has to do with the degrees of the numerator and the denominator. Okay, the degree of my numerator is a 1. It's x to the first right here. But the degree of my denominator is actually 2. because x times an x plus 12 would be an x squared plus a 12x. So I have this 2 right here. And up here I have this 1. Now, when the degree of the numerator, if the degree of numerator is less than the degree of denominator, does anybody remember what that is? Then the horizontal asymptote will be the x-axis. It'll have one horizontal asymptote right here, and that will be, and it says type an equation, y is equal to 0, which is your x-axis. Anytime the degree of the numerator is smaller than the degree of the denominator, y is equal to 0 will be your horizontal asymptote. Now next, they ask you about determine the oblique asymptote. If one exists, one doesn't exist on this because, hopefully you remember, you can only have a horizontal or an oblique. You cannot have both. You can have one or the other, or you can have neither, but you can never have both. There is a horizontal asymptote, so no oblique exists. All right. Next. All right. They want you to figure out where the function would intersect with either your horizontal or your oblique asymptote. Determine the points, if any, at which graph intersects the horizontal asymptote. That's when you just set them equal to each other. The horizontal asymptote was y is equal to 0. So if y is equal to 0 and r of x is also equal to all of this, then 0 is equal to all of this, which is x plus 8 over an x times an x plus 12. And now you need to solve for x. You just set them equal to each other to figure out what the x-intercept is, or what the x coordinate of the intersection point is. And you can use that trick on this again. I need to clear out my fractions, so I'm going to multiply both sides by an x times an x plus 12. And what you do to one side, you got to do to the other. But the nice thing is on the left, I'm taking all that blue stuff times a 0. Anything times a 0 is a 0. And then over on the other side, the denominator gets canceled out. So I'm just left with the x plus 8, which means x is a -8. So it will intersect at the point x is -8 and y is 0. Because remember, I knew what the y coordinate was. Y was 0. That goes right here. So we've got choice A. The graph of R intersects the horizontal asymptote at the point. It does say right here, type an ordered pair on this one. For some reason, they want the whole pair. There you go. It's just a coincidence that it also happens to be what is that? We found that earlier for some reason. What was that? Oh, the X-Intercept. Yeah, X-Intercept. Okay, and then the last one. Sorry, and then the last one. says use the real zeros and the numerator and denominator of R to divide the x-axis into intervals. And I should have left more room here, and I didn't. I tried to get these both on the same page. So let me add in another slide. Sorry about that. Okay, so they want me to use the real zeros. All right, use the real zeros of the numerator and the denominator of R to divide the axis into intervals. My real zeros were, the denominator was 0 and -12, and then the numerator was -8 when I was doing all that zero business. So here's a number line. I got 3 zeros. From left to right, -12 is the smallest, then -8, and then 0. So that divides this into 1, 2, 3, 4 intervals. All right. The first one goes from -infinity up to the -12. This one in yellow goes from -12 to -8. Actually, I probably should have just done it all in black, sorry. The blue one is between -8 and 0, and the green one is from 0 to infinity. Okay, so I'm going to make a table now of those 4 intervals. And you just pick any number you want in these intervals. And you're going to plug and chug into the function. All right. And the function was, what was the function? The function was x plus 8 over x times and x plus 12. All right, so pick a number, any number, it doesn't matter. Let's see. I like even numbers. I don't know why. So in the pink one, between -12 and -8, I'm going to pick -10. In the yellow one, no, I'm not, because I wrote that one down wrong. That wasn't -12 to -8. Hello. The pink one was from -infinity up to -12. Sorry about that. Okay. But I still like even numbers. So -infinity to -12. The next smallest even number would be -14. In the yellow, that's where I'd go with -10. Between -8 and 0, I'd probably use -2. And between 0 and infinity, now, between 0 and infinity, yeah, I'll just use 2. What the hell? You can use 1 if you want. You can pick any whole number you want or any fraction. There's an infinite number of numbers you could pick in these 4 different intervals, so choose wisely. And now you're going to plug and chug those 4 numbers into this guy. So for the pink one, it's going to be -14 plus 8 over -14 times -14 plus 12. That's going to be -4 over, let's see, -14 plus 12 is -2. -2 times -14 is a +28, which would reduce to -1/7. So for the pink one here, I get a -1/7. That is negative, so it is below the x-axis. That means it's going to be in quadrant 3 or 4. In that interval. For the next one, okay, -10, this is going to be -10 plus 8 over -10 times -10 plus 12. You guys can use your calculator if you want. It's -2 over -10 times +2 is -20. Negative added negative is a positive, and that reduces to 1/10. So I get a positive 1/10. So that's a positive. So it's above the x-axis. It's in quadrant 2, 1, or 2. Okay, the next one is going to be -2 plus 8 over -2 times -2 plus 12. -2 plus 8 is 6. -2 plus 12 is 10 times -2. 10 times -2 is -20, and that reduces down. I don't even have to reduce it down. I just need to know whether it's positive or negative. But since I'm an obsessed math teacher, you know, I would cut that in half. That'd be -3/10. That is the y-coordinate, which is a negative value. So I'm back below the x-axis. And last but not least is the positive 2. And so that one's going to be 2 plus 8 over 2 times 2 plus 12. So that's what? 10 over 2 plus 12 is 14 times 2 is 28, which reduces down to 5/14. So yep. And that's a positive, right? So it came out to be positive, so it's above the x-axis. There we go. So below, above, below, above. So when I go back to the slide that asks me, that gives me my multiple choice questions or choices, I know some of it's above and some of it's below. Choice B only allows for below, and choice C only allows for above. So it's got to be choice A. And what I came up with was that my aboves, the aboves were the -12 to -8, comma, and the other one that was above was 0 to infinity. And then the below was the other two, which was the two that were negative, which was -infinity to -12, comma, and -8 to 0. So, you know, just to color code this. The -12 to -8 was my yellow. And the 0 to infinity was green. And -infinity to -12 was pink. And the last one was blue. Okay. And now you got multiple choice. Use the results from the previous step to graph it. All right. I know that I have 2 vertical asymptotes, one at -12 and the other one at 0. So starting with my vertical dashed lines, that automatically eliminates A and B. They have, it looks like, the -12, but where's 0? I see -12 here, but where's 0? This one has -12 and 0. This one's -12 and 0. Then I look at my horizontal asymptote, which was the x-axis, And again, this has A and B have the wrong horizontal asymptotes too. So those are way wrong. So it's either C or D. And they look identical except for the way the graph is going. So remember, it's going to be above, let's see, the above is between -12 and -infinity and 0 and infinity. It has to be above the graph. If you look at C from -infinity, or sorry, from -12 to -8, and you may have to click on your magnifying glasses to get a good look at this, but it's the blue that's the graph. So I'm looking for yellow and green are above, pink and blue are below, negative. Okay, I can work it from the very first interval. If I look at the graph from left to right, if I'm looking from -infinity up to -12, which would be this much of the graph. Let me get a blue pen here. There we go. Their graph here is right there. And here it's right there. And our pink is supposed to be below. This is supposed to be below, so it's got to be D. It's got to be D. That's it. Okay, so that finishes up number 5. And then, oh my gosh, then I did number 7, and I did number 10. I'm going to go a little bit quicker on these because I'm running out of time. All right, so on this one can be factored. You can factor this one further. So it's going to be choice A, and I can factor out a 7 from the numerator and a 6 from the denominator. So this goes in here. Then it says, what's the domain? So the domain would be the denominator. Sorry, I forgot my parenthesis right there. The denominator cannot equal 0 for the domain. And the 6, since I factored it out, it doesn't have an x with it. So really, it's just the x plus 5 that cannot equal 0. So x cannot equal a -5. That would be choice C. Right there. Just type in -5. Another positive affirmation. Next question pops up. Put R of X in lowest terms. When we factored it out before, we had this. And unfortunately, after we factor it, I can't reduce it. 7, 6 doesn't reduce, and I can't cancel an X plus 1 with an X plus 5. So it's already in its lowest terms. Then to find the X-intercept, you would stick in 0 for Y. To find the Y-intercept, you'd stick 0 for X. When I did those, the X-intercept, I got answers for both. The X-intercept, it crossed at -1, and the Y-intercept was at 7/30. Remember, you stick 0 in for Y and solve for X. When you stick 0 right here, you'd multiply both sides by 6x plus 30. That would cancel out. So you're just left with the 7x plus 7, or you're just left with the numerator, and this would be a -1. So that's where this comes from. The other one, the 7/30ths, you get the Y-intercept by letting X be 0. Well, 7 times 0 plus 7 over 6 times 0 plus 30. This is 0 and this is 0, and 0 plus 7 is 7. 0 plus 30 is 30. Right there, 7/30ths is my Y-intercept. That was a quick way of doing that. To determine the behavior of the graph at any x-intercepts. The x-intercept we just found was the -1. And since that came from, remember the x-intercept we got from sticking 0 here, and then of course that canceled out. So we ended up with x equals -1. This is a degree of 1. That is an odd degree. So it's going to cross at -1. So B. Am I going too fast? And then it says determine the vertical asymptotes. The vertical asymptotes is where the denominator doesn't equal 0. And we did that earlier. We said this can't equal 0, and we ended up getting what we subtracted 30 and divided by 6 can't equal a -5. So it only has one vertical asymptote, and it does say type an equation. That's because it's an imaginary line. And so the asymptote would be x equals -5. I guess if you're looking for an asymptote, you're looking for where it does equal 0. So x equals -5. That would be the equation, because it's an imaginary dotted line going through the x-axis at -5. Okay, and then it says determine the behavior of the graph on either side of the vertical asymptotes. Remember here's your vertical asymptote, there's only one, and my 6x to the 30th, which is what I used, that's a first degree, which is odd, which means its behavior is up on one side, down on the other. So one side's going towards positive and the other's going towards negative infinity, all right? So that's going to be choice B, and what was it, -5? Yes, it'll approach that -5. It's either going to be doing it like this on one side and like that on the other. Like that on the other. Or vice versa. It could be doing something like this on this side and then something like that on this side. One side is going towards positive infinity, the other going towards negative. Not quite sure yet which. And then determine the horizontal asymptote. Okay. That has to do with the degree of the numerator compared to the denominator. All right, the degree of the numerator is 1, and so is the denominator. If the degree of the numerator equals the degree of the denominator, it's actually the ratio of the leading coefficients. My leading coefficients are the 7 and the 6. So the 7/6 is where my horizontal asymptote would be. And it says type an equation. Now this is a horizontal. Horizontal lines go through the y-axis. So this will be y equals 7/6. Okay, and of course, if there's a horizontal, then that makes the next question very easy. There's no oblique. Boom, done, moving on. Okay. All right, and now we're looking to see, does the graph of R actually intersect your horizontal or oblique? My horizontal was, y equaled 7/6. So you're going to take 7/6 and put it right here. This is going to be fun. I'm going to put the 7, 6 where the R of X is and set that equal to the 7. If you don't mind, I'm going to put this in factored form because it is a little easier when it's in factored form. Okay. All right. I have to solve for X. So I'm going to multiply both sides by 6 times and X plus 5. So that on the right side, the 6 cancels the 6 and the X plus 5 cancels the X plus 5. On the left side, the 6 cancels the 6. I am still left with the 7 and the X plus 5. I'm just going to leave it in factored form. And then that's going to equal the 7 times the X plus 1. And then if you want to take a shortcut right here, you can divide both sides by 7. Boom, 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 boom. Those go away. Running out of room, come over here. I'll have an X plus 5 on the left, and I'll still have an X plus 1 on the right. But right here, when I go to get all my X's on one side, guess what happens? They cancel out. You're left with 5 is equal to 1. 5 does not equal 1. So that tells me that there's no solution, which means C. There is no point at which the graph of R intersects my horizontal asymptote. Okay, and then it says use the real zeros on the number line. So I have to draw myself the table. I'll start with my number line here. And my real zeros, our real zeros were, there was only 2 of them. It was the -5 for the denominator and the -1 for the numerator. So on this one, I'm only going to have 3 intervals. This one, this one, and this one. -infinity to the -5, -5 to -1, and -1 to infinity. So between -infinity and -5, pick a number. I'm just going to use -6. Between -5 and -1, pick a number. I'm going to use -2. Between -1 and infinity, I will definitely use 0. Now I will spare you the math since I'm like I am out of time pretty much. I'll just tell you what the numbers came out to be. When I plugged and chugged in the -6, I got 35/6, which was positive. So that's above. When I plugged in -2, I got a -17/8, which is negative. So that's below the x-axis. And when I stuck in 0, I got 7/30, which was positive. So that's above. And so I've got 2 that are above and 1 that is below. So I need the choice that has both above and below in it. So that's C. And then my above is the yellow. I'll make sure I'll put the yellow interval in and also the green interval. All right. Come on, highlighter. And then my below would be the purple interval. I'm being really lazy here, but you'll type in those intervals, okay? Are you with me? Purple, green, instead of me writing those words down, and yellow. And then last is the correct graph on this. So after careful consideration of my horizontal and vertical asymptotes, I eliminated choices B and D. Those were the wrong vertical and horizontal asymptotes. So it was either, yeah, oh no, C has the wrong horizontal. It's A. A has the correct horizontal. Yep, So I did that one based on those alone. All right, I'm out of time, and I had a whole other couple of examples to go. So good God, look at all that. I had a bunch more. I'll have to finish this up on Wednesday. It's putting me even more behind, but we'll get it done. Does anybody have any questions? Anybody still out there? Yes, a few people. If not, bye.